Hello and welcome back to the Fullerton College Prepress class. This is, again, the Prepress Review, section 6.8 from our textbook, and this is Professor Ben Hewitt. I will attempt to wrap this up in this last video. Here's hoping. So let's talk about the major printing processes. We have letterpress, flexography, gravure, screen printing, lithography, and non-impact, including digital. Letterpress is the traditional stuff started in China millennia ago, but first really introduced to the West in the 1450s by Johannes Gutenberg. That's what you think of when you think of printing oftentimes. Lead type that you stick ink on top of and stick paper to and mash down with a giant wooden press. Yeah, that's letterpress, although it's gotten more advanced since then. Flexography is similar, except that it uses flexible rubber plates that wrap around cylinders and print with all sorts of types of ink on all sorts of types of substrates. Gravure, you should think money printing. That's your engraved printer, where someone will actually scratch with special carving tools into a metal plate that then gets flooded with ink into those little scratches and then printed. Screen printing, make yourself custom t-shirts, custom apparel, custom backpacks with printed images on textile. It's useful for other things too. Basically, you pass ink through a stencil that's mounted on a mesh screen of some sort. Lithography and offset lithography uses the oil versus water theory to control where the ink goes. Instead of making a physical, like all the other processes so far in this list have been a physical way of controlling the ink. When you get to lithography, you're using a chemical way of controlling the ink. And you have a flat plate, either it's made out of real metal or it's made out of real stone and is a traditional litho stone, or it's a piece of chemical coated metal. But either way, parts of it are greasy and like ink, which is made out of oil, and parts of it are hydrophilic and like water. The water and the oily ink don't mix with each other and they force each other apart, controlling where the ink goes. And lastly, non-impact printing, nothing touches the paper. Things like electrostatic and inkjet printing, just charge it and then, statically attract ink particles onto the paper or spray it out of a tiny nozzle. And that's non-impact. Paper is made from cellulose fiber, which is part of wood, but not all the wood. It also has something else called lignin that you get rid of. When you make paper, the paper gets some attributes, some characteristics based off of how it's made. A Fourdrinier paper machine is the standard way of making it. And basically, the wood is ground down and mixed with chemicals to turn into a pulp, kind of like a giant spit wad. Or if you want to be more natural about it, kind of the way that wasps make their nests, really, but on a large mechanical sense. And then out of this head box where all the pulp is, it gets squeezed through an opening onto a moving conveyor belt that's made out of wire that drains water, sucks water out through suction boxes, rolls it flatter, rolls it wider, squeezes the water out, smooths the surface, and makes a giant roll of finished paper as it dries and rolls it out like a giant piece of dough. Now, because this happens, that means there's a side of the paper that's smoother and a side that's not. The side that touches the dandy roll is called the felt side, and it is often smoother than the wire side, which is the face down on the wire belt side. It's not always that noticeable, but it's there. The wire side will be more absorbent for ink. The smoother felt side will be more resistant to ink. So you'll get different characteristics. You've seen this on notebook paper for school. The front side of the paper they sell you often has much thinner little blue lines for your college or wide rule paper you're writing on. And that magenta margin line is all nice and crisp. On the back there, look like someone wrote with a Sharpie, all kind of spread out and bled into other parts of the paper. That would be the wire side, which is less smooth and less resistant to the ink. Moving on. Paper folding. One of the things that happens in bindery is paper gets folded. Most print jobs get folded one way or another. It's folded into a brochure or it's folded into a signature for a book. Not all of them, but most. Other things that happen are trimming, you cut off edges, drilling, which is kind of like punching holes, but through a huger stack of paper, saddle stitching, which is like stapling, but with a giant sewing machine with a giant spool of wire, and perfect binding, which is gluing sheets together. Finishing is different than binding. Binding just puts the paper together and does the basic things to end the job. Finishing is something nice. It's an extra little flourish. It's a cherry on top of the sundae here. Finishing is lamination, numbering, foil stamping, embossing, die cutting, and converting. Converting is assembling die cut things. An envelope is a common die cut and converted thing, where it started as a big flat sheet, it got cut into the shape of the envelope and folded and assembled before you bought it. That's converted. Digital output. So if you're doing prepress, it used to be stuff that was all done offline by individual people working manually with manual hand tools. Now it's all done on a computer through a prepress workflow solution. It's one efficient integrated system that does things like PDF creation, pre-flighting, trapping, imposition, ripping, and output. When you're making a PDF, you want to make sure that you're getting the page size correct. You want to make sure that the PDF version supports the color space and any effects you're using. You want to make sure the images are compressed to the level you're going to want. Remember your Nyquist theorem, 300 dpi at the size you're using, or different if you're using another type of printing. Make sure the fonts are embedded, so if you send it to another computer, it doesn't have to find the fonts to print the object. And make sure the color is managed to the artist's original intent. Now, the raster image processor, the RIP, will take PostScript or PDF and convert it into machine pixels. Machine pixels is a grid of 256. That's a funny number. 256 pixels. And these pixels are either turned on or off to help make the halftone dots. So this is actually generating your ability to make variations on a halftone dot size depends on the amount of machine pixels you can give per halftone dot. That's the output resolution. So even if the plate maker says 2,400 dots per inch, I mean, that's great, but those dots are what's being used to make the 150 bigger dots per inch that actually does normal high quality printing. Now, how these halftone dots are used is also determined by the software and also by use. You can use all or none, or you can use a combination. AM screening is amplitude modulated. That means that the halftone dots are arranged in a neat square grid no matter what. And when you want more color, the dots get bigger. When you want lighter or less color, the dots get smaller and more of the paper is seen. This is like my marching band example. In the band, you have the little 30-pound flute players marching in the front, and you have the big guys with the sousaphones and the bass drums marching in the back. But the actual grid the band is marching on, assuming they're competent, doesn't change. The spacing between lines is the same. The spacing between people is the same. So the back of the band looks a lot, no offense to us brass players and percussionists, looks more dense in an aerial picture because we're covering more of what you see. There's more people and more instrument back there. It's more stuff, but it's still on the same grid. That's AM screening. FM screening is frequency modulating. And that means that the dots are the same size. And when you want darker colors, they get closer together. When you want lighter colors, they get farther apart. This is really cool and works better for some things than others. In photographs, especially of things that are difficult to do with like pastel colors or flesh tones, FM screening is great at hiding the halftone dots and making it more random so your brain is not interrupted by the printing process when you're looking at the picture and you just see the picture. And because you're not aligning them on top of other dots, they're all random, or as random as a computer can be. Let's be real here, guys. But because they're not in a regular pattern, they don't create moires. They don't make interference patterns where the dots line up and make you see the other things and other shapes. Moire patterns happen because of our visual system, which works by combining shapes of objects to see the greater whole. Like when you see a car go down the road, you see a car. You don't see 4 rubber tires and the rims and the doors and the windows and the mirrors and a hood and an antenna with a little jack-in-the-box antenna ball on top. Sure, you might notice all those about the car, but when you see it go by, you recognize the whole object, don't you? You recognize, oh yeah, it's a car. And if you see your friend walk into the room, you see your friend. You don't see hair and eyes and face and clothes and fingers and shoes and shoelaces. No, you see the whole person, and then you can notice the details later. So anyways, moire patterns work by tricking our problem, because sometimes if dots make random patterns that you think you recognize, your brain will say, hey, I see a shape there, even though there isn't one, not really. So FM screening kind of eliminates that or reduces that a lot. Digital proof technologies. Inkjet sprays tiny droplets of ink. Pretty straightforward. Non-inkjet can be, I would say they didn't include laser printing, like Xerox stuff, but oh well, that's fine. Non-inkjet is a ablative system where you have 4 sheets of fully covered in ink that it will then laser off the parts you don't want and transfer the rest to your paper. This way it can create accurate halftone dots that are exactly the same as your plate maker is going to make. It takes longer and it costs a lot more, but it's a lot more accurate to the final output. Soft proofing means you're sending someone an image on a computer screen to look at. That means they can look at it without ever visiting you in person. Anything monitor based can be done here. The book will tell you that it's okay to do this with special systems for even color accurate contract proofs, but I would hesitate. You can't control the other person's experience enough, and they can even just have a cluttery desk, which makes them see color different. Because your color is always you comparing one color to another. And it's hard to get a good isolated color-free environment that is appropriately boring for you to see color correctly. Anyways, but it can be done using an LCD computer display. Plate setters make plates. A computer to plate system. This will take an offset printing plate and use lasers to image them. The lasers will turn off part of the plate. Either the plate comes with the whole thing likes water and hates ink, or the whole thing likes ink and hates water. And the laser will turn off one or the other part so that when you use it, some of it likes ink and some of it likes water the way it needs to. It's way faster than doing traditional plate making involving process cameras, film, and exposure tables, and way more accurate too. You can get much finer halftone dots and much more consistent output, and with using even lower skilled people to do it, although there's still skills involved. Let's be clear here. Trap, it's a trap. Trap is overlap. Trap is, if you're going to print two colors next to each other, there's no way they're going to line up exactly right to just meet and touch and kiss right there on the edge. Good luck. Maybe it'll happen on the first few sheets, but as the press runs and the paper changes and the humidity in the print shop changes and the paper changes size, or the machine kind of relaxes into its rhythm, you're going to get some variations. Trap overlaps colors slightly so that you never get it. This is kind of like wearing a long shirt and tucking it in so that when you bend over, no one sees a gap on your back. But for printing, typically it's between 2 and 6 thousandths of an inch. It's very small. If you're doing screen printing multiple colors, you want to create this stuff manually, and it'll actually be like a whole point or two, because screen printing is much harder to line up plate to plate. Imposition is arranging your pages onto a sheet, onto a press sheet, so that you can print them more efficiently. Imposition will mean for a book that you're using signatures. They'll be lining up the pages in whatever direction and page order is necessary for them to show up in the correct order when folded and trimmed. Imposition styles are sheetwise, which means you use one plate per side of the paper. Work and turn and work and tumble is different directions of flipping it, but that means you have the front and the back of two copies of what you're printing on the same plate. So you only make one set of plates, and you flip the paper over and you print it a second time to get the other half. And that way you only make one plate or set of plates, and you don't have to do twice the work. But that only works when your plate is double the size of your output. Work and turn and work and tumble just means you're flipping it over different axes. Multi-up means you put more than one onto the sheet. So if you're printing business cards, that's the most common place for a multi-up. You're not going to print one 2-inch by 3.5-inch business card on a 20 by 14-inch press sheet, are you? Please just say no. Lie if you have to. No, you're going to fit as many on there as you can. You want to get the most efficiency for time, energy, and money as you possibly can for your print shop. So you put as many things on there crammed as you possibly can with reasonable success of being able to trim it later. And a combination typically means you're doing multi-up and one of the others. All right, guys, we made it. That's it for this class. That's it for this semester. That's it for the book. That's all, folks. I'm not really good at that impression. Anyways, thank you so much for watching through too many videos with me and sticking through this whole long class of too many videos with me. Hope you're not permanently tired of my voice, and I hope you've learned something. Hope you learned a couple things. At least how much bleed to use, which is 1/8 of an inch, and how to use the pen tool. Anyways, the pen tool is from the class, not from this video. All right. Thank you so much, and this is goodbye.